In this video, we want to apply the concepts used in the last video, and we want to be able to find the changes between points, and we want to also be able to find the distance between points. So let's consider 2 points that are right here. So this is point A, which will be at 4, 1, and point B, which will be right here at 2, 5. So to get from point A to point B, we would have to go to the left in the x direction. Okay, so how far do we have to go to the left? Let's work this out down here. Delta x is clearly 2 units to the left, but I could find that by taking the, how could I get 2? I could take the x unit for B, which is 2, that's where I ended up, and I had started at 4, so this would give me a change in x that is -2, which indicates that it should be 2 units to the left. I can find my change in y, be this line right here. Clearly that is 4 units up, but if I want to calculate that, I could take my y value for B, which is 5, and know that I had started at a y value of 1 at A, so I had to go up a distance of 4. So the ratio delta y over delta x, the rise over the run, would be 4 to -2. Sometimes we'll write the negative sign out front. We could say that's a -4 to 2 ratio, or a, if we want to simplify that, a -2 to 1 ratio in terms of the rise to the run. Now we want to figure out how far apart the points are. So let me draw in the diagonal. And we can sketch in our triangle, and you can do it 2 different ways, but I'm going to look at the lower triangle, not the upper triangle, and I've already determined that the one side has a length of 2, and the other side, that would correspond to my delta x being -2, so it's 2 units in size, and the change in the vertical side would correspond to my delta y. We know that's 4 units in size. So how far apart are the points? We can apply the Pythagorean theorem, and we can say that the distance from A to B, put absolute value signs around that, would be 2 squared plus 4 squared. That's actually what the square of the distance from A to B would be. So the square of that distance is 4 plus 16, which is 20. And so the distance from A to B is the square root of 20. How big is the square root of 20? It's somewhere between. So if I were to look at that, 4 squared would be 16, which is less than 20. So the square root of 20 is more than 4. And 5 squared would be 25. So the square root of 20 is less than 5. That makes sense when you look at the picture. That purple line is between 4 and 5 units long. Let's consider one more example. Let me clear the ink. Let's start with point A again and put that at 4, 1. But let's consider point C at -2, 4. And we want to once again find the change in the y value, the change in the x value, and the distance between the points. So if I wanted to find out how much the x value had changed, I could literally count squares, but it always works if you want to find the change in something, it's where you ended. So the x value that you ended at is -2 minus where you began. You began at 4, an x value of 4. So the difference in those numbers is -6. That's exactly how many units you had to go to the left. You had to go 6 units to the left to get from A to C. Likewise, we can figure out delta y. It's pretty clear you have to go up 3 units, but let's work that out. So we could get that by saying that we ended at a y value of 4, but we had started at a y value of 1, and the difference between 4 and 1 is 3. So we had to go up 3. Putting these together, delta y over delta x is a 3 to negative 6 ratio. If I wanted to, I could call that a negative 1 to 2 ratio for the rise over the run. Now let us consider the distance that we have between the points. So I can create a rectangle here, which is a 3 by 6 rectangle, and we want to find the length of the diagonal. And to find the length of the diagonal, the best thing to do is consider it to have two right triangles, one in the bottom left and one in the upper right. I'm going to consider the one on the bottom left. It is 6 units wide, so if I wanted to find the length of the hypotenuse, its value squared better be 6 squared, plus the height of that triangle squared is 3, so 3 squared. And when I put those together, I have 36 plus 9. That gives me 45. Now, once again, that line is clearly not 45 units long. The length of AC is the square root of 45. And let's try to compare that to the nearest integers. If we took 6 squared, that's less than 45. And 7 squared would be more than 45. So the length of that diagonal is between 6 and 7 units long, which makes sense when you look at the grid lines.